Okay, so we are going to do 5.2 today, which is graphing quadratics in standard form. So in 5.1 we found all the properties, and today we're going to work on actually graphing. So using those properties in order to graph. So our goal will be to graph a quadratic function in standard form. So, first we have a little bit of review. So for all quadratic functions in standard form, f of x equals ax squared plus bx plus c, the following rules will apply. The axis of symmetry is found at x equals the opposite of b over 2 times a. The vertex has an x that is the same as our axis of symmetry, because the vertex falls on the axis of symmetry. In order to find the y, you're going to plug in x. Once you have that, you're good to go. So now we're going to actually use this function here to find all of our properties, just like we did yesterday. So I'm actually going to pause the video, and you're going to go through just like you did on your assignment and find those things. Okay, so you should have been able to get at least this far. So plugging in the opposite of b over 2a, you should get x equals 1 for your axis of symmetry. You're going to use 1 comma, plug that 1 in to get negative 8 for your vertex, 1, negative 8. The positive a value tells you your graph is going to open up, meaning it has a minimum value. 0 comma, you're going to plug in 0. That turns into 0, that turns into 0, minus 6 is 0, negative 6. Your x-intercepts, we did not talk about that yesterday. So we didn't figure out how to find those yet. If you were to try and plug in, because I know x is a number and then that's 0, I'm just going to show you what this would look like. 0 equals 2x squared minus 4x minus 6. There is not a way to get x alone, because these two terms are not like terms. You cannot combine them. And you would sit there and try to manipulate it in many different ways. It's not going to work. Okay? So in this case, what we're going to do is we're going to graph it, and then we'll come back up here and record our x-intercepts. So whenever we go to make this table, we always start with the table. The middle of our table is going to be our vertex, just like we did when we did absolute value functions. We always put our vertex in the middle and found points on both sides because it's mirror imaged. So this 1, negative 8 is going to be the middle. Remember, we count up as we go down. So if this was 0, 1, 2, 3, this would be negative 1 up here. Then what we're going to do is we're going to plug in all of these. So 2 times negative 1 squared minus 4 times negative 1 minus 6. Using a scientific calculator, be careful. Make sure you're using parentheses. It's very important that we always use parentheses. Oops. We're going to get 0 here. If you hit second enter, then you can just go back in and put in 0. It's negative 6. Plug in 2. We're going to get negative 6, which is good because you should see that mirror image just like when we were doing absolute value function. Plug in 3, and that one's 0. So you can see along both sides of that vertex we have that mirror image. So from here you actually can see the x-intercepts. You'll notice that this and this are x-intercepts, because there's something comma 0. So at that point you could plug those in, or you can also wait until we actually graph them, because we're going to do that next. So let's go ahead, now that we have this table of values, we're going to graph. I'm not going too far negative, so I'm going to kind of put this shifted in that direction. And I don't have any positive points, so I'm also going to put my x-axis up here because I don't have to worry about graphing in the positive y's. I'm gonna plot these because I'm only going to 3. I'm gonna go by halves. There's 1, there's 2, there's 3. Because I have plenty of space, so I'm just gonna space out my axes. I need to go down to -8, so I should just be able to go by 1s. And I'll have plenty of space. Alright. Now, when I go to plot these, -1 is at 0. I plot that point here. 0 is at -6. I plot that there. 1 is at -8. 2 is at -6. And 3 is at 0. Now, when you go to connect these points, it's very important that you're careful when you do so. Do not make it look like a V. Do not take a straight edge and connect these and make it very rigid. It is a U shape. So I always start down here and actually make it rounded in a U. And then make sure you're going towards this one. Now what you could also do is you could find another point in between. So like, because we have that, you could plug in -0.5. And that's going to be at -3.5. So that's where it's going to cross in that spot. Because you're going to really have to be careful when sketching where that U goes. Which means this one would also be here at 3.5. So it looks something like this. Now, you also have to make sure that your arrows go up and continue off the graph because it does continue in that direction. One thing that I see wrong every year is people will draw this U and they'll either draw it like this once they get past that point, which is not true because you're telling me then that 3.5 is here up at 1. And if I plug in 3.5, that's not accurate. So if you draw going off the graph inaccurately, you will actually get marked down on a quiz. So we need to make sure that this goes off the graph. And it can't go back in either. It can't be like this kind of shape. Okay, we have to make sure that every point on this U is represented as closely as we can make it. Okay. We can see now from our graph that our x-intercepts are at -1, 0, which I put on there, and at 3, 0, which is also on there. Now, as I showed you, this you cannot solve. However, I am going to give you another example of one that you would be able to solve. So, that's our only example we have for graphing. But let's say I gave you this function here, f of x equals 3x squared minus 24. And I said find the x-intercepts. And I know that my x-intercepts are x comma 0. So if I plug in 0 for y, I get 0 equals 3x squared minus 24. Add 24 to both sides. 24 equals 3x squared. Divide by 3 on both sides. 8 equals x squared. Now, when you divide, now you're going to take the square root of both sides. And when you do so, you're going to have x equals positive or negative square root of 8. Now, if I were to put that into a calculator, I get approximately positive or negative 2.83. Now, I wouldn't ask you to, find something, it wouldn't be something like that. I would keep things exact. But I just want you to see that those are, you can solve this. You can find these two intercepts. And if I were to ever tell you something like this and it wasn't exact, I would tell you you could round probably to the nearest hundredth or thousand. So this would be 2.83 comma 0 or negative 2.83 comma 0 because it could be positive or negative. So that would be an example of when you could actually solve to find your x-intercepts. And that only happens because there's not a b value there. And so there's only x squared x only shows up once, so you would be able to do that. So looking at your assignment, you have two graphs on the front. You will have to find x-intercepts, but since you're graphing, it should go totally fine. And on the back, you have another two graphs, and you have a story problem. Okay. Now, it says a person walking across a bridge accidentally drops an orange into the river below from a height of 40 feet. I don't even care what that says. It gives you this function right here. Okay. That function gives you the approximate height. H is the height. After t seconds, t is time in seconds. Graph the function. So you have to graph it. What is the height of the orange when it hits the water? So how high is the orange when it hits the water? And then it says, in how many seconds will the orange hit the water? If you look for that height in your graph, you should be able to find it in your graph to figure out that time. If that time is between two values, you could plug in the height and solve for time, because in this case, you only have one t variable. So that would be an option as well. So let me know if you have questions, and I'll see you guys soon.